In previous lecture, I discussed size of the set and power set. Today, I will discuss Cartesian product. Before Cartesian product, first you need to understand what is ordered pair. Definition 7. The ordered n-tuple A1, A2 till An is the ordered collection that has A1 as its first element, A2 as second element, and An as the last element. So it's in a order. First element is A1 and last element is An. Two ordered n-tuple are equal if and only if each corresponding pair of their element is equal. In other words, we can say A1, A2 up to An equals to B1, B2 up to Bn if and only if Ai equals to Bi for I, 1, 2 up to n. Means A1 equals to B1, A2 equals to B2, A3 equals to B3, An equals to Bn. Then we can say these both are equal. It's about order n-tuple. If there are two elements, then we can say order two tuples, and that is called as ordered pair. Suppose A, B and C, D are equal, then A should be equals to C and B should be equals to D. So A, B is an ordered pair and C, D is ordered pair. AB is not equals to BA unless A equals to B. So one ordered pair like this AB, it is not equals to BA. Both are different. Next is definition 8. It's about Cartesian product. Let A, B be set. The Cartesian product of A and B denoted by A cross B. We use this cross symbol for Cartesian product is the set of all ordered pair AB where A belongs to A. There are two sets, one is A, another is B. So there will be set of ordered pair small a and B. Here A belongs to this set A and B belongs to set B. So you can say A cross B equals to AB. A belongs to A and B belongs to B. Let's see one example. Example 14. What is the Cartesian product of A equals to 1, 2 and B equals to A, B, C? We need to find Cartesian product of these two sets, set A and set B. So we need to make pairs that will contain element from both set A and set B. So first 1A, then 1B, then 1C. So we did pair 1 with all element of set B, A, B, C. Next I will do pair of 2 with A, B, C. So 2A, 2B and 2C. So now A Cartesian product B will contain 1A, 1B, 1C, 2A, 2B, 2C. So here these individual are ordered pair that we constructed from both set A and set B. First element is from set A and second element is from set B in each ordered pair. And A Cartesian product B is not equals to B Cartesian product A unless A equals to B or both are phi. So A Cartesian product B will be equals to B Cartesian product A if A equals to B, or even both are phi. A equals to B equals to phi, then A Cartesian product will be phi and B Cartesian product A will be phi. Next, definition 9, it's about multiple Cartesian product. Here we just take Cartesian product of two set. How can multiply, how can do Cartesian product of multiple set? So the Cartesian product of the set A1, A2, An, all are individual set. It can be denoted by A1 cross A2 up to An is the set of order n tuple, and here A1, A2 up to An where Ai belongs to Ai. This small ai is in order tuple and this upper Ai is the set name. And I value vary from 1 to n. So in other word, we can say A1 cross A2 up to An equals to small a1, a2 up to An, and Ai belongs to Ai. means this A1 belongs to set A1. This A2 belongs to set A2. AN belongs to set AN. So we can also do multiple set Cartesian product. Let's see one example. Example 15. What is the Cartesian product of A cross B cross C? Here we are multiplying three sets where A equals to 0, 1, B equals to 1, 2, C equals to 0, 1, 2. There are three sets. So in every order triple, let small a, b, c. This A belongs to set A, B belongs to set B, C belongs to set C. Let's do Cartesian product. So it will contain 0 from set A, then from set B 1, from set C 0. Now from set A again 0, from set B again 1, from set C we can take 1. I am doing in a sequence, you can do in any way. Next, again from set A 0, set B 1, from set C 2. So every order triple, first element is from set A, second element is from set B, third element is from set C. Like this we will do 0 to 0, then 0 to 1, 0 to 2. Next 1, 1, 0, 1, 1, 1, 1, 1, 2. Next 1 to 0, 1 to 1, 1 to 2. And how many order triple will be created? Here 2, here also 2, 2 multiplication 2, here 3. There will be 12 order triple. In example 14, here 2, here 3. So 2 multiplication 3, it will be 6. Now just count 1, 2, 3, 4, 5, 6. So size of set A multiplied by size of set B. That will be Cartesian product size. So here size of all set, like 2 multiplied 2 multiplied 3, it's 12. We can also do Cartesian product with itself. So we use the notation like A square. A square is for A Cartesian product A. Then AQ is for A cross A cross A. A power 4, it's for A multiplied 4 times. Let's see one example. Example 16. Here A contain 1, 2. Now we need to find A square. So 1, 2 Cartesian product with 1, 2. So 1, 1, then 1, 2, then 2, 1 and 2, 2. It will contain 4 ordered pair. Next AQ. AQ means set A will multiply 3 times. So there will be 8 order triple. 2 multiplied 2 multiplied 2, it's 8. And each triple contain one element from this 1, 2, then one element from this second 1, 2, then one element from the third 1, 2. This is first set A, second set A and third set A. We are doing cross product of A 3 times. So it will contain 1, 1, 1, 1, 1, 2, 1, 2, 1, 1, 2, 2, 2, 1, 1, 2, 1, 2, 2, 2, 1, 2, 2, 2. Always do in a sequence that it will help you to track. So with this I am finishing Cartesian product, also set. In next lecture I will discuss set operation. If today's lecture is helpful for you, please like, share and subscribe. Thank you.